Integral calculus is a very good scoring point. It only comes in IIT, not in ISI. So integral calculus is a very scoring point where you can, it's like very normally, it's very easy to understand. Okay, so I will be also spending some more time on that. Anyways, coming back to limit and continuity, first I will define what is a multivariate function.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISI MStat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
So till this point of time, you have learned how to deal with functions like from R to R, right? For example, fx is equal to sine x, fx is equal to x squared, and various other odd functions. Then we draw the graph of this function in R2, right? Now, what do we mean by the graph of this function in R2? Let's say we draw a function like this. What do you mean by the graph of this function in R2? So this is a point in 2D, right? So this is a point x comma y. So what does it denote? So this is actually a curve in R2. A curve. Another possible curve is this. This is another possible curve. But this is not a function because why? For same x, you have multiple values. So a function when drawn in a 2D plane, it's nothing but a very special form of a curve in 2D, okay? Where curve in 2D, where the x coordinate is x and the y coordinate is f of x, where f is the function. This is denoted by the curve, this curve. Now, how do I do this curve? How do I denote this curve? So a very good example of such a curve is what? It's a circle, right? So how to represent circle in 2D? Mathematically. So represent it as another parameter. Let's say you can represent cos t comma sin t. You can represent this in this way. It's called parametric form. So therefore the question comes that any curve in 2D, can you represent it in the form f1t comma f2t? Any curve in 2D, can you represent it in the form f1t comma f2t? That's the next question. Like, is there such a formula for this curve? f1t comma f2t. Because it's a plausible curve, right? The answer turns out to be yes, it's true. The reasoning is very easy to understand. That imagine what you're doing. You're actually mapping the real number line to R2. It means you're taking the real number line and you're turning and twisting it. This entire infinite real number, turning and twisting it to get into here. You're turning this entire real number line and twisting it. Turning and twisting it to get into this format. That means you're mapping this R, this entire real number line in R2, point by point. This is how you do it. So how do you define it? Any R to R square is defined as f of t, because it's taking one point t, right? And giving 2-point outputs. So therefore each point will be a function of this t only, right? Which is its input is taking. Any point is being going here, this point. So each t is being transferred to some f1t comma f2t that is dependent upon that corresponding t. So therefore, any curve in 2 dimension is denoted like this. Similarly, any curve in in n dimensions, imagine a curve, imagine the curve that a mosquito or a bee makes while moving in your room. That's a 3-dimensional curve. It is represented by f1t comma f2t. Three different, each coordinate represents 3 different functions. That's natural because each coordinate is dependent upon what values it's taking in and it's giving out the output. So each coordinate is in itself a function from R to R. F1t, Fit is nothing but itself a function from R to R. Example is sin t comma cos t comma sin t. Okay, so the question is, the natural abstract mathematical question comes here in your in a human mind is that how can we define R to the power m to R to the power n, any m and n integers, natural numbers, I should say. M and n are natural numbers. How can we define? We know that how to define a function R to R. We understood how to define a function from R to R to the power n. How to define from R to the power m to R to the power n. It's very natural. So R to the power n, so understand it's taking input what? It's taking input m numbers, x1, x2. It's taking input m numbers. x1, x2, xm. M numbers ka input it's taking. And it's giving output n numbers. y1, y2, yn. So since it's taking input m numbers, each yi must be dependent upon this m numbers. So you can write that as f1 of x1, x dot xn. This y2 as it's dependent upon this m variables, right? You write it as f2 of x1, dot xm. Similarly, you write yn as fn, x1 dot xm. So therefore, each of the yi is a function of these individual parameters. Okay. So therefore, you can observe that functions from R to the power m to R to the power n, R to the power m to R to the power n is made up of functions like this. What are these functions? These are taking input, understand this very carefully. These are taking input m numbers like this. They're taking input m numbers like this and giving output only one number. So it's a function from R to the power m to R. So therefore, each of these individual fi is a function from R to the power m to R. So therefore, this complex functions from R to the power m to R to the power n is made up of these easy functions R to the power m to R to the R, R to the power m to R.
To book a trial class for your preparation courses of IIT MS, ISI MStat, and CMI MStat Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Stay tuned and stay blessed.